Now let's ask how fast the procedure that we just described for index creation actually is. Let's assume there are n documents, m words, and on the average w words per document. For example, in the case of the web, n will be a really large number, maybe in the millions, billions, or trillions. M will be another large number, perhaps not as large as n, but quite large nevertheless. And W may or may not be very large because every document may have a few thousand or a few 100,000 words, but certainly not billions of words. Let's see now what the answer is. We have our index structure here, we have our documents, and we assume there are n documents, m total possible words, and on the average W words per document. First thing we notice is that every word in each document needs to be read at least once. So the complexity is at least order NW. Additionally, as each word is read, we need to look up this sorted structure of words to figure out whether or not it has already been inserted before. The cost of looking this kind of a structure up is log m, as we have seen earlier. For example, if a balanced binary tree is used to store these words. Further, we must insert the URL of the document against the word if we happen to find it already in the index. Else, we must insert an entry for that word if we don't find it, and then insert the document against it. Now we claim that each of these is just a constant cost per word. Obviously, the second part, which is inserting a blank entry for a word like worm with just one fresh document, is clearly a constant cost once we know where to insert the word worm. But suppose the word already exists and there are thousands of documents already against it, then it's not that clear that it's a constant cost to insert the fresh ID in an existing long list of IDs. So there's an important assumption that this is going to be a constant cost, and the reason for that assumption we'll come to in a later lecture. But for the moment, we'll go ahead with that assumption. If either of you missed it in the homework and got confused, that's okay, because you were thinking pretty well. But for the moment, we're going to make this assumption, and therefore the complexity of our procedure is order NW log m, using a balanced binary tree to store the words, and assuming that entering a fresh document in an existing list against some word is a constant cost.